All right, folks. So this week we were sent a CSV file, which I've saved to my desktop here, and we were told make a time series graph of this flash data. We went 5-minute bends, and yeah, it looks like on his example graph, we have flash count per 5 minutes and the time in UTC. So let's see what we can do with this and see if we can try to recreate this graph, but in Python. So I'm going to go ahead and quit out of my mail app before I accidentally show off all of my emails. And I'm going to open Visual Studio Code. And the first thing I'm going to do is I'm going to make a project folder for this. So let me go ahead and click on Open for this. And I'm just going to shove it in my downloads for now. I'm going to call it time series demo and create, and just open this folder. This will point Visual Studio at this open folder. If you're using Spider or Jupyter or what have you, get to a working directory where you will work on just this project and build like this project. That way you keep your stuff organized. I'm going to just copy in the CSV file and we can take a look at it. So I have an extension installed on Visual Studio Code, which is called the CSV viewer. I believe it's in the extension for it. It's called Excel viewer. So if you want to install this extension, you can. That's kind of optional though. I'm really just here to, I'm just going to open it with this Excel viewer so that we can see what it looks like in an easier to read format. So we have flash number, which 1, 2, 1, 1. That's kind of an interesting column in that I'm not exactly sure what's going on there. We have number of sensors reporting, Julian day plus hour. It's not as nice of an extension maybe as I thought it was, if it appears to have crashed. Oh well. Try that again. What in the world? Okay. Okay. So we have flash number, Julian day plus hour fraction, which is an interesting thing that I have never heard of before. We have hour fraction, second fraction, latitude, longitude, altitude, chi-square, and distant from HLMA center. So, all right. I am totally lost as to what the time units are, not gonna lie, but let's see what we can make out of this. I'm gonna create a new file and I'm going to call it timeseries.py. When I type the py, Visual Studio should recognize this as a Python script, and it will immediately put it in Python mode, and it will start discovering Python interpreters. We're going to be sure that we're on our Atmo environment. So you can see I'm currently not. I'm going to do select interpreter path, find, and then go to my home folder. That's interesting. Mamba Forge for me, but it'll be probably Mini Forge for y'all. To then envs. Sorry, I did that really confusingly. Let me back up just so that I can show more clearly what I'm doing. Interpreter path, find, then to home folder. It'll be Mini Forge for y'all. Environments, Atmo, bin, and then find Python in here, which for me is right here. Select. So the first thing I'm going to do is, since we're going to be working with a giant CSV file, that is kind of Panda's specialty, is working with tabular data. So I'm going to import pandas as PD, and then we can go ahead and get started. So the first thing I'm going to do is read in the CSV file. So I'm going to call it a variable called HLMA data. And we're going to say that that is pandas. I've imported pandas as PD just as a shorthand, and also because like most people who use pandas will import it as PD, so it's kind of become standard. So I'm going to do pd.read underscore CSV, and then just the name of the file, which is HLMA underscore 211218 underscore flash underscore 1.csv. One thing that I do when I'm coding is I'll use these double quotes. Most people who do Python use single quotes. I didn't learn Python, it was not my first coding language, and the double versus single quotes actually mattered in the language that I learned first, whereas in Python it doesn't. So you'll see most people use single quotes because it's easier. I'm using double quotes because old habits die hard, and I'm used to using double quotes. So just to verify that this works, I'm going to do print HLMA data, and then the script will exit. So I'm going to click run, and we should get this output here. So we can see that it's read in and it's printed out the CSV file successfully. So that's good. I'm going to go ahead and I'm actually going to change displays really fast. Don't worry about them. Okay, I'm recording. Good. Stand by. Let's bring this over here. Okay. Okay, so we've printed off our table, so we know that's working. All we really need to do is bin the data into 5-minute intervals, and then once we have the 5-minute intervals, then we can just plot it on a line graph. So for me, I think the part that I'm most confused about, just looking at it, is this Julian day plus hour fraction. And then we have hour fraction, and then we have second fraction. So what is interesting is that we can see that the first second fraction is 448, and the last second fraction is 86,400, which if you've ever taken any sort of class that involves the Coriolis parameter, you'll recognize 86,400 as the number of seconds in a day. Not necessarily, you don't have to take a class that involves the Coriolis parameter, but that's how I recognize it at least. So I'm going to go ahead and assume that this is the number of seconds since the start of the day. I'm not sure that that's true, but we're going to go ahead and say that that's true because that's what I think is true. And if we're graph it and I'm wrong, then we will know probably almost immediately. So we're going to be working with dates and times here. So I'm going to go ahead and import the datetime library, which is a part of standard Python. So it doesn't actually matter if you're in an environment or if you have the datetime package installed, it comes with Python. So most people, well, I'm going to do from datetime import datetime as DT. This is somewhat standard. Some people leave off the as DT and just do from datetime import datetime, but I like the DT because it makes it less taking. So I'm going to go ahead and say that the start of day is going to be a variable is equal to datetime, and our day for this, at least according to the plot that he emailed us. Stand by 1 second. Let me pull that back up. There it is. So 29 April 2020 was the day that this occurred, which is an interesting date. So I'm going to go ahead and just put in the year is, I'm actually not sure that's right because the file is named 211218. So let's Google what a Julian day is. How about that? Julian day today. Today's Julian date is 22,050. So Julian day 352 would have been I'm gonna guess that since this is December 18th, 2021, based on the file name, that the 352nd day of the year, second day of 2021, sure enough, was Saturday, December 18th. So I'm gonna assume that the start date was Saturday, December 18th. I'm not entirely sure if that's right, but we'll see what happens. And that this example graph is not exactly what we're trying to reproduce, but we're just trying to produce something similar to it, but for a different day. That's what I'm going with. I could be dead wrong. So anyway, the syntax for creating a datetime object is you do dt, or datetime if you left off the dt, and the as dt up here. I'm pointing at my screen as if you can see my finger. Sorry. If this isn't there, then you would type out the whole word datetime, but since it is there on mine, I'm putting just dt, and then I'm going to say 2021 for the year, and then it goes year, month, day. It's like descending, so it starts at the biggest and then goes to the small. So year, month is December, the day is 18th. Start time in hours, and you can see like I'm getting a suggestion here where it goes year, month, day, hour, and it highlights the one that I'm currently on. If I go back to day, it turns day blue, and then when I go to a comma, it this hour. So the hour is 0 for midnight, the minute is 0 for the first minute after the day started, and second is 0, and microsecond is also 0. We can leave off the time zone. We don't actually need that for what we're doing. And that goes into a deep rabbit hole that we don't need to cover right now. So the first thing I'm going to do to this table is I'm going to create a new column called datetimes. So I'm going to say HLMA data datetimes is equal to I'm going to try doing start of day. That's not going to work. We're going to need to do a for loop to iterate over every single one of the elements in this array. So I'm going to say for, I will say num seconds in HLMA data, and the column is called second fraction. And just to demonstrate what's going on here, I'm just going to do print num seconds. And then I'm going to comment this out for the moment and run it. And what this should do is it should print off every single, every time that there was a flash, it should print off the number of seconds since the day started that flash occurred. And we can see that that's what we saw there for a second. And what this for loop, what this for statement is doing, should back up. I realize a lot of y'all have probably never coded before. Is it is going through this CSV file, which would be nice if it would open in the previewer, and it is looking at the is looking at the second fraction column. So here we go. It's going to the second fraction column, and it's saying print every. It's just saying start with the first item in this column, store it to a variable called num seconds, and then print it. And then it goes to the next one and print it, and the next one and print it. And so all the way up through the end, and then it just stops. So my terminal doesn't have all the history of it, but if we actually scroll down to the bottom of this table, which I'm not sure if I'm going to be able to do because this doesn't really appear to be, the pretty CSV viewer doesn't appear to be very functional as I'm learning. But let's see, I'll try it. Okay, we can see that the last are 86,400, and then we scroll up. This terminal output matches what's in this CSV. So that is indeed working. What I'm going to do now is I'm going to create a list called flash date times list, flash DTs list, and I'm just going to create it as a blank list. Then what I'm going to do is I'm going to say that the time of the flash is equal to the start of the day plus the number of seconds since the day started. And so in order to do that, we're going to need to import a library called time delta, which is a part of date time. And so this statement, I'll back up. Do from date time import time delta. That will import the time delta module from the datetime library. But in this case, since we're already importing something from datetime, we can just do import datetime as DT and then also import time delta, kind of a shorthand notation. So what I can then do is I can say for num seconds in HLMA data as second fraction, say that the time of flash is equal to start of day plus time delta, and then say seconds equals num seconds. And then I'm just going to do print time of flash for the moment. So it's not actually doing anything with this variable other than just spitting out in the terminal. But as we'll see in a second, we can get it to do things. I'm just going to run that again. And we can see that we now have date time objects where it's the year, month, day, and then the time. And this is useful because we now have a Python datetime compatible object representing the time of the flash. I should be clear, I'm doing all of this datetime stuff so that we can get to the 5-minute binning part. Once we have the 5-minute bins, then we can plot things more easily. So I'm going to go ahead and say that what we can do is this flash DTs list. We can add the time of flash to that list. So if I do flash DTs list dot append, which means add this object to this list. So we have flash DTs list append time of flash. So what we're doing is we're taking this flash DTs list and we're just adding this object time of flash to the end of it. And then outside the for loop now, I can do print flash DTs list. And this will print one single list after the entire thing is done. It's kind of a mess and I wouldn't really want to read it, but what we've done now is we have essentially a column of times that is the same length as this CSV column. And we can add that column to our table. And so what I can now do is I can say HLMA data, create a new column called pi date times. And then I'm going to say equals flash DTs list. And then I'm going to turn this print statement back on. So we'll get one output at the end. And we can see that we have this new column called pi date times over here on the far right. And that represents each flash has been associated with a Python datetime. So now what we need to do is figure out how to bin these into 5-minute intervals. The first thing that I'm going to do is the way pandas works is we have columns. We have flash number, Julian day plus hour fraction, second fraction, lat, lon, alt, chi-squared, distance, and number of stations reporting, and then our new column pi date times. But then we also have this one column here on the far left that's unlabeled, and this is called the index column. So basically every single row gets an index. It starts at 0 and it goes all the way up to whatever the last index is. And so right now it's just a series of sequential numbers. What we can do is we can actually make the pi date times column the index column. And so that's useful because then we can do things like slice every 5 minutes on the index, but that's kind of, we'll get there when we get there. So I'm going to go ahead and do is we can say HLMA data equals HLMA data dot set index, and I believe we wrap this in brackets and then we say pi date times. I'm not sure I'm right on that, and if I'm not, then I will have to look back at some old code. I need to print it to be sure though. HLMA data. Okay, yeah, so this column here has been moved over to the far left, and you see how the label isn't in the same line? That's indicating that it still has this label by date time, but it's actually the index column now. Now what we need to do is, see, so what I would do in this instance, and this may or may not be the most efficient way of doing it, I'm trying to think of how to do this quickly and cleanly. But I think what I'm going to do is kind of the quick and dirty way that doesn't require much thinking because I don't, yeah. Um, if somebody thinks of a better way to do this, I'm sure there are better ways of doing it than what I'm about to do. But what I'm going to say is I'm going to section off a day into 5-minute intervals. And so what I'm going to do is I'm going to say current, let's see, say current time equals start of day dot copy, which is just going to create a copy of the start of day variable and store it into current time. And now what I'm going to do is I'm going to create a while loop to say while current time is less than start of day plus time delta. And this is going to be kind of complicated to explain before I'm finished doing it. So I'm just going to do it and then explain what I'm doing afterwards. So time delta days equals 1. And then I'm going to say current time. I'm just going to print current time. Then I'm going to print current time plus time delta minutes equals 5. And then I'm going to print a new line character to kind of section these off a little bit. And then I'm going to say current time equals current time plus time delta minutes equals 5. So what this is going to do is I'm saying perform this loop continuously until current time is equal to 1 day after the start time. So, and then what I'm doing is I'm saying, what's the current time? What's 5 minutes from the current time? And then add 5 minutes to the current time. So what this is going to do is it's going to print midnight. It's going to print midnight plus 5 minutes. And then it's going to internally add 5 minutes to current time. And then it's going to print midnight plus 5 minutes, midnight plus 10 minutes, new line. Then it's going to add 5 more minutes. Then it's going to midnight plus 10 minutes, midnight plus 15 minutes, add 5 more minutes. Midnight plus 15, midnight plus 20, add 5 more. And it's going to continue this until current time gets all the way to the next midnight. So midnight on the 19th. And then it will stop, hopefully. The reason that I'm only doing print statements for now is to verify that this works. It's always best to kind of test what you're doing before you do it, because then if it doesn't work, you won't spend lots of your time trying to do something that doesn't work. Again, I'm speaking from experience there. So I'm going to run this. And as we can see, we got a date time attribute has no, date time object has no attribute copy, which is not what I was expecting. I thought that every object has a copy attribute. Guess not. I'm going to get rid of this line for now, but I don't know what that's going to do here, because since current time is, I need to do current time equals start of day, but I am sure that that's not going to go so well. What did it? Okay. Okay, as we can see, that actually worked. We scroll back, we can see, I don't have the history for this, but you can see 3 a.m., 3:05, 3:05, 3:10, 3:10, 3:15, 3:15, 3:20, all the way through, continues this until it gets to 11:50, 11:55, 11:55 midnight, and then it stops. And then it prints the HLMA at the table because I forgot to remove that. So this line is in fact unnecessary. And then what we can do is, now that we have a way to section off everything into 5-minute bends, we can say that instead of doing 5-minute bends, we can do I really, really hope I was sharing my screen that whole time. I think I was. Okay. Well, I will have to redo this, I guess. So once we have, now that we're doing this in 5-minute sections, what we can do is we can say, let's index the CSV, the table, in 5-minute sections. So what I'm going to do is basically, again, I'll explain this once I've written it. So I'm going to do HLMA data, and then I'm going to do current time through, and that's denoted as a colon. And I'm going to say current time plus time delta minutes equals 5. And I'm going to store that. Well, I'm not going to store that to anything yet. I'm going to get rid of this, and then I'm going to turn this off because it's not necessary at the moment. Okay. Cannot get left slice bound for non-unique label. So what I think is happening here is that instead of what I'm doing is I'm trying to index by times. Let me go back to our, okay. So what current time is midnight when it starts, the first iteration is midnight and then midnight plus 5. And so what I think it's doing is it's going in here into the index column and it's saying, where's midnight? And since the first data point is at 7 minutes after midnight, it doesn't find it. And so it's not happy about that. So see if I can remember how to do this. Do HLMA, I believe it's HLMA data where dot index is greater than current time, greater than or equal to current time. And then I want to do, this is definitely wrong, HLMA data dot index is less than or equal to current time plus 5 minutes. I don't think that's going to work. Okay. Stand by. This is where we get to the lovely pandas documentation. So I'm going to just Google pandas data frame date time slice. I probably should have mentioned that a while ago. These, when I do HLMA data and I read in the CSV file, that creates what's called a pandas data frame. That's just the name of the object of this kind of object here. Anyway, I've clearly looked this up before, and this is a Stack Overflow post. So you set timestamp column, then you can simply use that. Additionally, if you only need one date, you can do that. Okay, this is what I'm looking for. So what I would do is I would say that it's in parentheses and there's a panda. Okay. So what I'm going to say is HLMA data.index is less than or equal to current time, like that. And then apparently this colon needs to be an and then go to the end and wrap this in parentheses also. We'll try that again. Oh, I'm not printing anything, so I actually won't know if this works other than it didn't crash. I probably should print something in a minute. I'm going to store this to an object called 5-minute bin. And then I'm going to print 5-minute bin. And this is also taking a while, which is kind of concerning. If that ever happens, at least on Linux and Mac, you can press Control-C to keyboard interrupt, which will basically just stop whatever you're doing. So let's try that again. And let's see. Okay. So Oh, I did not. I got rid of the, when I did current time to start of day in this while loop, I got rid of the part where it adds 5 minutes to current time. And so this will just run forever because this while loop will never exit. So that's not good. Again, press Control C. On Windows, I don't know. I think it's also Control C. But yeah, I guess worst case scenario, you can exit Visual Studio Code. And yeah, that's one way to do it. So let me go ahead and say current time equals current time plus time delta bracket 5 minutes equals 5. Okay. That's a little bit more like it. So we can see that each one is 10 columns still. And there's a different number of rows in each one, I assume based on how many flashes actually occurred in each 5-minute period. And we can see that these are binned into 5-minute intervals. So I have 2330 through 2334, and then here I have 2355 to 0000. So that seems to be working. So that's good. Now all we really need to do is just add the number of these flash counts into a array and add the date into an array, and then we can plot them. So I'm going to go ahead and say make another list called list of times equals list, and I'm going to make another list called list of counts list. So what I'm going to do now is I'm going to say every time that this goes through, I'm going to say list of times dot append current time. And then I'm also going to do list of counts dot append. And then I'm going to say length of 5-minute den. And let me actually, I'm going to comment this for the moment. And I want to be sure that this length works the way I think it does. Usually when you call length, it'll do, I want to be sure that it's doing number of columns and not number of rows or some kind of 2-dimensional thing. So let me do print list of, well, no, length of 5-minute then. I think that does rows, but I want to be sure. That seems to be good because every time it's printing a row, the length matches the number of rows. So that's what we want. So I can go ahead and get rid of this and uncomment and uncomment. And then what I can do is I can say, yeah, append those to the lists. Then and run this. Actually, I don't need to print this anymore either. So that should work. I'm going to go ahead and print after the while loop exits, print list of times, and then print list of counts. So we can see we have our date time list here, which is long and noisy. And then after that, we get another list here that is the number of flashes in that count. So now we can go ahead and make our plot. So I'm going to import matplotlib, which is the kind of standard Python plotting library. So it's going to be from matplotlib import pyplot as plt. Typically, that's what people do, is they will import just the pyplot module and they will import it as plt. And similar to pandas, how everyone imports pandas as pd, everyone imports pyplot as plt. And so if you're ever searching on the internet like we did a second ago, if I bring us back, actually, we can see These guys were using df for the data name. They didn't actually ever call PD, but if they had, they probably would have used PD. I was hoping to show an example there. I didn't really get a good one, but anyway, PLT for matplotlib. So I'm going to go ahead and type in, yeah, that should work. We're going to make a new figure, which is, I'm going to call it fig equals plt.figure. And matplotlib has a concept of figures that then have axes embedded in them, and the axes are what actually shows the plots. So we need to get a reference to the axis that we just created. So I'm going to call it ax equals fig.gca. GCA stands for get current axis. So that should allow us to get a handle to our axis. And then I'm going to say ax dot, I'm going to go for a scatter plot for now. And I'm going to, for the x-axis, I'm going to do list of times. And for the y-axis, I'm going to do list of counts. And for the size, I'm going to do just 1 for all of them. And the color, I'm going to specify as black. And that should be good. Finally, I'm going to do a fig.savefig test.p. I don't know why I call it test. That sounds like we're not confident. I call it output.png. So if we go ahead and run this, we see we have a new file, output.png. If we open this, we can see this is our plot. So one of the things that can be useful is, this is a scatter plot just because I did a kind of a list of points. But if you wanted to, you could actually change this to plt.plot and remove the scatter size. And this should do a line graph instead. Except that I misspelled the word plot. Cool. Try that again. So this looks a little bit more like Dr. Logan's example. We kind of have a bit of a problem here where the data just peaks out. And this would be something that I would usually send a whiny email to Dr. Logan about, because do I mask this out and therefore possibly misrepresent, like, you know, that would be ignoring data, which is typically bad. But also there is something to be said for the communication of what you're trying to demonstrate. And clearly you're trying to demonstrate that there's a lot of labelling here. And this may be some sort of sensor error or something. So if you run across something like that, that would be something that you want to be careful of. But for now, I'm just going to leave it in. And also for the moment, I'm going to, one of the other things is that along the bottom here, you can see that our axes are actually like the labels of the times are, it's first of all, it's date, and then it's month, day, hour, month, day, hour, month, day, hour. Since all of these are from the same day, we don't really need the date repeated every single time. And maybe useful to change that slightly. So this gets a little bit complicated in that I have done this before where I've changed the formatting of things like that, but I believe it requires a separate input. So I'm going to go ahead and bring up some of my old code. And by old, I mean relatively recent. This is something that I'll reference quite frequently, is code that I have written before. So I know that in this Python script, I wrote something about changing the, yes, here it is. Okay, so it was x-axis set major formatter. Is from matplotlib import dates as plt dates. I don't know if there's a standard alias for that, like the as plt dates. I'm not sure how many people actually do that, but that's what I do. So there you go, I guess. Welcome to the club. And it was, I'm just going to copy this for the moment. And I'm going to say ax dot x-axis dot set major formatter, and then call your PLT date, whatever you imported that as, .date formatter. And then there's this weird code, and I'm sure that by the end of this, everyone will be quite familiar with those codes. But there's a cheat sheet on stricttime.org, which it's a long story as to why it's called what it is, but basically these codes get translated into date time. So into like strings where I can have it. So you see I have %time n / %time d, hour, minute, capital H, capital M. And if we look on here, then we have minute, a capital M, a hour, a capital H, and then month and day. So in this case, we really only want hour, minute. So I can get rid of all of that, and we can run this again. And hopefully we'll get a little bit better formatted plot. There we go. And finally, let's say we want to add some labels to this. So first of all, we can set a fig dot. I can never remember if it's fig.title or fig.setTitle. So I'm just going to do fig.title, and I'm going to say HLMA flash count 12 December, right? 18 December 2021. Let's try and run that and see if it's title or set title. Yeah, no attribute title. So I think it's set underscore title. It is actually subtitle, super title. I forgot they changed that. So there we go. There we go. So now we have our we have our HLMA flash count title up top, and that looks good. I'm going to put a y-axis label and say ax.set underscore y label. And I'm going to say in Dr. Logan's plot, he has it as HLMA VHF flashes per 5 minutes. So I'm just going to copy that pretty much word for word. Say HLMA VHF flashes. The per 5 minutes, he actually has a nice latex formatted exponent to the -1. That's much more difficult to do than you would expect, so I'm not going to bother. And I'm going to say per 5 minutes, fill it out. There's kind of the easy way out, but it gets the same message across. I'm also going to set an X label and just call it, I think I'll just call it time, which I can't remember if that's what he has it called. Yeah, he has a time UTC, which is actually more accurate. So UTC. And there we go. So I think that basically replicates the plot that he has, and we've done it entirely using Python. So congratulations on filling this out. This code will be available on my GitHub shortly after this. So if you want to look at this for your own reference, I will have that online on Canvas. So yeah, thanks everyone for attending, and I hope you learned something.